The genetic history of Europe is like a grand puzzle, pieced together over tens of thousands of years through waves of migration, mixing, and later isolation. From the early hunter-gatherers who trekked across vast landscapes, to the farmers bringing new lifestyles and technologies, and finally, the nomadic herders from the steppes, each group has left a lasting imprint on the DNA of modern Europeans. In this video, we'll explore the fascinating story of these migrations and how they've shaped the genetics of Europe today. Around 45,000 years ago, one of the first groups to settle in Europe were the Western hunter-gatherers, often referred to as WHG. These early humans migrated into Europe during the last ice age, at a time when the landscape was harsh, dominated by cold climates and vast glaciers. But they weren't alone. Europe at this time was also home to Neanderthals, a distinct species of humans that had been living in the region for hundreds of thousands of years. The two groups occasionally interacted, and through these interactions, interbreeding occurred. This left an indelible genetic mark. Today, almost all non-African people, including Europeans, carry around 1 to 2% Neanderthal DNA. When we look at modern Europeans, the influence of WHG is particularly pronounced in areas like the Baltic states and among the Basques in northern Spain. These populations carry a higher proportion of hunter-gatherer ancestry, a reminder of the early humans who thrived in Europe long before farming or complex societies emerged. Then, about 9,000 years ago, a transformative migration began: the Neolithic farmers. These people came from the Fertile Crescent, a region in the Near East known as the cradle of agriculture. They brought revolutionary ideas: farming, animal husbandry, pottery, and more complex tools. For the first time in history, humans in Europe could grow their own food, build permanent homes, and support larger communities. So, what did these early farmers look like? Based on genetic studies, we know that Neolithic farmers generally had darker skin compared to modern Europeans, with brown eyes and dark hair. This contrasts with the lighter complexions that developed in Northern Europe over time. These traits, along with their shorter, more robust stature, are distinct from the later populations that would come to mix with them. As these Neolithic farmers spread across Europe, they came into contact with the local hunter-gatherers. Over time, they didn't just replace these groups, they also intermarried and shared knowledge. This blending of cultures and genes created a new mixed population that gradually transitioned Europe from a world of wandering hunters to one of settled agricultural societies. Genetic studies show that the DNA of these early farmers still makes up a large part of modern European populations, especially in southern Europe. For example, places like Sardinia and the Greek islands show particularly high levels of Neolithic farmer ancestry, preserving the genetic legacy of these first agricultural pioneers. Their influence isn't just in the genes, but also in the technologies and practices that laid the foundation for European civilizations. The next major migration came around 5,000 years ago, and it was just as transformative. This time, the migrants came from the vast Eurasian steppes, an expansive region of grasslands stretching across what is now Ukraine, Russia, and Kazakhstan. These people, known as the Yamnaya, were nomadic herders and warriors. Their mastery of horseback riding and wheeled carts allowed them to cover huge distances, reaching deep into Europe. The Yamnaya are not only significant for their mobility, but also because they brought with them the Proto-Indo-European language, which would eventually evolve into many of the languages spoken in Europe today, including Latin, Greek, and the Germanic and Slavic languages. Their arrival had a massive impact on the genetic landscape of Europe. Studies show that in some parts of northern and central Europe, Yamnaya ancestry makes up around 50% of the modern gene pool. In regions like Scandinavia, Germany, and even the British Isles, the genetic signature of these steppe nomads remains strong. It's fascinating to think that this ancient group not only influenced the languages we speak, but also left a lasting imprint on the genetics of millions of people. The genetic history of Europe is a rich and intricate story, one that spans millennia and countless generations. As science continues to unlock the secrets of our ancestors, we gain a deeper understanding of how the continent was shaped, from the hunter-gatherers to the farmers, and from the Yamnaya to the people of today. The legacy of these ancient populations lives on in each of us. But discoveries continue to rewrite our understanding of the past. For example, in Greece, Scientists recently unearthed a 190,000-year-old Homo sapiens skull, pushing back the timeline of when modern humans first inhabited Europe. Findings like these remind us that our history is far more ancient and complex than we once thought, and there are still countless chapters of our human story waiting to be discovered.